In this work, we propose UV volumes, which achieves the first deformable, real-time rendering, and editable NERF. Given multi-view videos of a moving human, we perform high-fidelity novel view synthesis that supports real-time rendering. The left is multi-view videos of a performer. The right is our generated freeview video. For editability, we can easily edit the shape of the reconstructed human by changing the shape parameters of a human model, while preserving interview consistency. Also, we can edit the pose of the performer by changing the pose parameters of a human model, while keeping the texture untouched. Benefiting from the disentanglement of appearance and geometry, we can edit the texture by drawing patterns on the 2D texture. As shown here, the rich texture patterns are well preserved and transferred to correct semantic areas in different poses, which demonstrates that the texture is not only changed as expected under the edited frame, but also transferred to a novel frame with the model dynamics. Moreover, given any arbitrary artistic style, we can render a 3D dynamic human with the transferred texture. We decompose a dynamic human into 2D neural texture stacks and 3D UV volumes. Specifically, we propose the pose-driven and view-dependent 2D neural texture stacks, which encodes high-frequency human appearance. And we present the 3D UV volumes that encode smooth and view-independent densities and texture coordinates. This allows us to use much smaller and shallower neural networks to model only low-frequency signals in 3D, thus achieving real-time rendering. Here is our framework. Given a human pose theta, we generate 3D UV volumes and a 2D neural texture stacks in 2 branches. We render the UV volumes to obtain the texture coordinates, and query the neural texture stacks to get the color via these coordinates. Then, we optimize the photometric error between the renderings and the ground truth images to train our network. To warm start the UV volumes and regularize its solution space, we leverage the pre-trained dense pose model as an auxiliary supervisor, by applying semantic loss and UV metric loss between dense pose outputs and our UV images. Given noisy UV images and semantic labels from dense pose, such as the red circles, we can reconstruct proper UV volumes, like the blue circles, under the intrinsic multi-view constraint of minimizing the photometric error between renderings and ground truth, such as the green circles. As shown here, UV volumes successfully recover the UV images even though the provided dense pose supervision is incorrect. We also implement on the most challenging human 3.6M dataset, with only 4 views available for training. As shown here, our method generates high-quality appearance results in real time, even with rich textures and challenging motions. We compare UV volumes against SOTA freeview video synthesis methods on novel view synthesis. Benefiting from spatially aligning the appearance across different poses in a 2D texture, our method produces high-fidelity renderings, while other methods suffer from blurs, especially on letters and wrinkles. For reposing, baselines give distorted results, even split humans, while our method exhibits better visual quality with reasonable high-definition dynamic textures. The results indicate that using smooth UV volumes in 3D and encoding texture in 2D has better controllability on the novel pose generalization than directly modeling a pose-dependent neural radiance field. By changing the shape parameters of the simple model, we can conveniently make the human performer smaller, stronger, fatter, or slimmer. Our model also supports changing texture style and appearance. Given any fabric texture, we can dress the performer in various appearances, which enables 3D virtual try-on in real time.